Let's start by exploring how to perform a mouse hover action on a web element using Selenium WebDriver. In many web applications, hovering over a drop-down menu reveals additional options. Selenium provides the Actions class to simulate this user interaction. By creating an instance of actions and using the moveToElement method, you can hover over a specific element, such as a drop-down. Once the drop-down is visible, you can interact with its options using standard element locators and click methods. This approach is essential for testing dynamic menus and interactive web elements, ensuring your automated tests can mimic real user behavior accurately. Locating elements is a foundational step in Selenium automation. The By class in Selenium offers multiple strategies to find elements, such as by.id, name, className, or xpath. For instance, you might use By.id to target a dropdown or By.xpath to select a specific option within a list. Choosing the right locator strategy depends on the structure of the web page and the uniqueness of the attributes. Accurate element location ensures your tests are stable and less prone to failure when the UI changes. Mastering these techniques is crucial for building robust and maintainable test scripts. After hovering over a dropdown, the next step is to interact with its options. Selenium allows you to locate the desired option using locators like xpath and then perform a click action. This sequence is common in scenarios where selecting an option triggers further actions or navigation. By chaining these actions, you can automate complex workflows that involve multiple user interactions. This method is especially useful for testing navigation menus, settings panels, or any UI component that relies on drop-down selections. Selenium provides the getCssValue method to retrieve CSS properties of web elements. This is particularly useful for validating UI styles, such as colors, fonts, or dimensions, ensuring that the application meets design requirements. For example, you can check the background color of a button or the font size of a heading. By automating these checks, you can catch visual regressions early in the development cycle. This technique is valuable for both functional and visual testing, making your test coverage more comprehensive. WebElement class in Selenium offers several methods for interacting with and retrieving information from elements. Besides getCssValue, you can use methods like getText, getAttribute, and isDisplayed to gather details about elements. These methods help you verify that elements are present, visible, and styled correctly. Leveraging these capabilities allows you to write more intelligent and context-aware tests, which can adapt to changes in the application's UI and behavior. Beyond the basic getCssValue method, Selenium's WebElement class provides specialized methods for retrieving lists, numbers, colors, fonts, and dimensions from CSS properties. For example, getCssValueColor returns a color object, while getCssValueFont returns a font object. These advanced methods enable more precise validation of UI elements, especially when you need to ensure consistency across different browsers and devices. By using the appropriate method for each property, your tests become more reliable and detailed. Capturing screenshots is a vital part of test automation, especially for debugging and reporting. Selenium allows you to take screenshots using the getScreenshotAs method. This feature is useful for documenting test results, capturing errors, or providing visual evidence of test failures. Screenshots can be automatically saved to specified file paths, making it easy to review and share test outcomes with your team. Incorporating screenshots into your test reports enhances transparency and helps identify UI issues quickly. JUnit is a widely used open-source testing framework for Java applications. It provides a structured way to write and run unit tests, helping developers verify that individual components of their code work as expected. JUnit supports annotations, assertions, and test suites, making it easy to organize and execute tests. Its integration with popular IDEs like Eclipse and IntelliJ IDEA streamlines the testing process. By adopting JUnit, teams can catch bugs early and maintain high code quality throughout the development lifecycle. JUnit uses a set of annotations to control the execution of test methods. The @test annotation marks a method as a test case, while @before and @after specify methods to run before and after each test. @before class and @after class are used for setup and teardown at the class level, and @ignore allows you to skip specific tests. These annotations provide flexibility and structure, ensuring that your tests are executed in a predictable and organized manner. Understanding these annotations is key to writing effective and maintainable test suites. TestNG is another powerful testing framework for Java, designed to address some of the limitations of JUnit. It supports a wide range of test types, including unit, functional, and integration tests. TestNG offers advanced features like data-driven testing, flexible annotations, parallel execution, and detailed reporting. These capabilities make it ideal for testing complex applications and managing large test suites efficiently. TestNG's flexibility and comprehensive feature set have made it a popular choice among automation engineers. While both TestNG and JUnit are popular testing frameworks, they differ in several key areas. TestNG provides more advanced configuration options, such as test grouping, prioritization, and parallel execution. It also supports data-driven testing natively through data provider annotations, whereas JUnit requires external libraries for similar functionality. TestNG's reporting and logging features are more comprehensive, offering detailed HTML reports. Ultimately, the choice between TestNG and JUnit depends on your project's complexity and specific testing needs. Test configuration is a major differentiator between JUnit and TestNG. In JUnit, test cases are primarily annotated with @test, while TestNG offers a broader set of annotations, including @before test, @after test, and @data provider. This flexibility allows TestNG to support more complex test setups and execution flows. By leveraging these annotations, you can create modular and reusable test configurations that adapt to different testing scenarios. TestNG's ability to execute tests in parallel is a significant advantage for large projects. By running multiple tests simultaneously, you can drastically reduce the time required to validate your application. This feature is particularly valuable for continuous integration pipelines, where speed and efficiency are critical. JUnit, on the other hand, executes tests sequentially by default, which can be slower for extensive test suites. Data-driven testing allows you to run the same test script with multiple sets of input data. TestNG supports this approach natively with the @data provider annotation, making it easy to test various scenarios without duplicating code. In contrast, JUnit requires additional libraries to achieve similar functionality. Data-driven testing is essential for validating applications that handle diverse data inputs, ensuring comprehensive coverage and reliability. Effective test reporting is crucial for tracking progress and identifying issues. TestNG excels in this area by providing detailed HTML-based reports that summarize test results, failures, and logs. These reports are more comprehensive than the standard output provided by JUnit, making it easier to analyze and share results with stakeholders. Enhanced reporting capabilities help teams quickly pinpoint problems and maintain high-quality software. Managing large test suites is easier with TestNG, thanks to its advanced features like test grouping, prioritization, and execution order control. You can organize tests into logical groups, specify the order in which they run, and assign priorities to critical tests. These capabilities streamline test management and ensure that important scenarios are always validated first. JUnit offers basic suite management, but TestNG's flexibility is better suited for complex projects. Selecting between JUnit and TestNG depends on your project's requirements. For simple projects, JUnit's straightforward approach may be sufficient. However, for larger or more complex applications, TestNG's advanced features provide greater flexibility and efficiency. Consider factors like test suite size, reporting needs, and the importance of parallel execution when making your decision. The right framework can significantly impact your testing productivity and software quality. The Test Automation Framework provides structure and guidelines for designing, implementing, and maintaining automated tests. It typically includes test scripts, test data, drivers, reporting tools, and environment setup. Frameworks help standardize testing practices, improve code reusability, and simplify maintenance. By adopting a framework, teams can ensure consistency, scalability, and efficiency in their test automation efforts. A robust test automation framework consists of several key components. Test scripts automate user actions and validation. Test data provides input values and expected results. Test drivers control execution flow, while reporting and logging components capture results and errors. The test environment simulates different platforms, and automation tools like Selenium or Appium facilitate test creation and management. Together, these components create a cohesive system for efficient and reliable testing. There are several types of test automation frameworks, each suited to different needs. Linear scripting is simple and best for small projects. Modular frameworks break tests into reusable modules, improving maintainability. Data-driven frameworks separate test logic from data, enabling tests with multiple input sets. Keyword-driven frameworks use action keywords for flexibility, while hybrid frameworks combine multiple approaches. Behavior-driven development, BDD, uses natural language for better stakeholder collaboration. Linear scripting is the most straightforward automation framework. Test cases are executed in a sequential order, making it easy to implement for small and simple applications. However, this approach can become difficult to maintain as the number of test cases grows. It's best suited for projects with limited scope and minimal changes, where simplicity and speed are more important than scalability. The modular framework divides test cases into smaller, independent modules. Each module represents a specific functionality or feature, making it easier to update and maintain tests as the application evolves. By combining these modules, you can build comprehensive test suites that are both flexible and scalable. This approach is ideal for medium to large projects where code reusability and maintainability are priorities. Data-driven frameworks separate test logic from test data, allowing the same script to run with different input values. This is especially useful for applications that require extensive data validation. By storing test data externally, such as in Excel files or databases, you can easily add new test scenarios without modifying the test scripts. This approach increases coverage and reduces duplication, making your tests more efficient and comprehensive. Keyword-driven frameworks use a set of predefined keywords to represent actions or commands in test cases. Testers can create test scripts by combining these keywords, making it easier to design and maintain tests. This approach is highly flexible and allows non-programmers to contribute to test creation. It's particularly effective for complex applications where actions can be standardized and reused across multiple tests. Hybrid frameworks combine the best features of multiple framework types, such as data-driven and keyword-driven approaches. This makes them highly adaptable and suitable for complex applications with diverse testing needs. By leveraging the strengths of each framework, hybrid solutions offer flexibility, scalability, and maintainability, ensuring your automation strategy can evolve with your project. Behavior-driven development (BDD) frameworks use natural language to describe the expected behavior of an application. This makes it easier for stakeholders, including non-technical team members, to understand and participate in the testing process. BDD frameworks like Cucumber integrate seamlessly with Selenium, enabling collaboration and ensuring that tests align with business requirements. Keyword-driven and data-driven testing frameworks serve different purposes. Keyword-driven testing focuses on defining tests using action keywords, making scripts easy to create and maintain. Data-driven testing emphasizes running the same script with various input data, maximizing coverage with minimal code duplication. The choice between these approaches depends on your project's complexity and testing goals. Often, combining both yields the best results. In a keyword-driven framework, you might define actions like open browser, click element, or enter text as keywords. Testers then create test cases by arranging these keywords in a sequence, specifying the target elements and expected outcomes. This approach simplifies test creation, especially for repetitive or standardized actions, and makes it easier to update tests when the application changes. A data-driven framework allows you to run a login test with multiple username and password combinations from an external data source. Instead of writing separate scripts for each scenario, you use a single script that iterates through the data, validating each case. This method is efficient for testing forms, calculations, or any functionality that requires varied inputs. Read test data from Excel files. You can use libraries like Apache Poi in Java. The process involves loading the Excel file, accessing the desired worksheet, and iterating through rows and cells to extract data. This approach allows you to manage large datasets efficiently and update test scenarios without modifying your scripts. Reading from Excel is common in data-driven frameworks, supporting comprehensive and flexible testing. Poi and JXL are Java libraries for working with Excel files. Poi, an Apache project, supports both old XLS and new XLSX formats and offers extensive features for manipulating Office documents. JXL is a simpler library, limited to the older XLS format and basic operation. For modern applications and advanced Excel handling, Poi is the preferred choice, while JXL is suitable for lightweight tasks. Automating CAPTCHAs is technically possible but highly discouraged. CAPTCHAs are designed to differentiate humans from bots, using tasks that are easy for people but hard for machines. While some tools claim to solve CAPTCHAs using machine learning, most systems include measures to prevent automation. Bypassing CAPTCHAs is often unethical and may violate website terms of service. It's best to avoid automating these challenges in your tests. Test automation frameworks offer several advantages, including code reusability, maximum coverage, recovery scenarios, low maintenance costs, minimal manual intervention, and easy reporting. By standardizing your testing approach, frameworks help teams work more efficiently and maintain high-quality software. These benefits make automation frameworks an essential part of modern software development. Choosing the right automation framework depends on your project's size, complexity, and specific needs. Consider factors like test data management, reporting requirements, team expertise, and integration with other tools. The right framework should balance flexibility, scalability, and ease of use, enabling your team to deliver reliable and maintainable tests. Selenium, Appium, and Test Complete are among the most popular test automation tools. Selenium is widely used for web applications, Appium for mobile testing, and Test Complete for desktop and web apps. Each tool offers unique features, such as record and playback, test management, and reporting. Selecting the right tool depends on your application type and testing requirements. Following best practices in test automation ensures long-term success. These include writing modular and reusable scripts, separating test data from logic, using meaningful names, and maintaining clear documentation. Regularly review and update your tests to adapt to application changes. Adhering to these practices helps maintain a robust and effective automation suite. There are many resources available to help you master Selenium. These include official documentation, tutorials, blogs, and community forums. Topics range from tips and tricks, parallel execution, BDD integration, web scraping, and advanced reporting. Leveraging these resources accelerates your learning and helps you stay updated with the latest best practices. Running Selenium tests in parallel can significantly reduce execution time, especially for large test suites. Tools like Selenium Grid and TestNG's parallel execution features make it easy to distribute tests across multiple machines or browsers. This approach is essential for continuous integration and delivery pipelines, where speed and reliability are critical. Behavior-driven development, BDD, frameworks like Cucumber can be integrated with Selenium for more readable and maintainable tests. BDD uses natural language to describe test scenarios, making them accessible to all stakeholders. This approach bridges the gap between technical and non-technical team members, ensuring that tests align with business requirements. Selenium is not only used for testing, but also for web scraping. By automating browser actions, you can extract data from dynamic web pages that traditional scraping tools can't handle. This technique is useful for gathering data for analysis, research, or competitive intelligence. However, always respect website terms of service and ethical guidelines when scraping data. Selenium WebDriver can be integrated with browser dev tools for advanced testing scenarios. This allows you to capture console logs, monitor network traffic, and debug web applications more effectively. DevTools integration enhances your ability to diagnose issues and validate application behavior under different conditions. PyTest is a popular testing framework for Python, and it integrates seamlessly with Selenium for web automation. PyTest's simple syntax, powerful fixtures, and rich plugin ecosystem make it a great choice for writing scalable and maintainable tests. Combining Selenium and PyTest enables you to automate browser actions and validate web applications efficiently. Selenium WebDriver can also be used with JavaScript, enabling automation for web applications built with modern frameworks. JavaScript-based testing tools like WebDriver.io provide a rich set of features for browser automation, making it easy to write, run, and maintain tests in JavaScript environments. The field of test automation is constantly evolving, with new tools, frameworks, and best practices emerging regularly. Stay updated by following industry blogs, participating in forums, and experimenting with new technologies. Continuous learning ensures that your skills remain relevant and your automation strategy stays effective. In this video, we covered advanced Selenium techniques, compared JUnit and TestNG, explored different automation frameworks, and discussed best practices for effective testing. By mastering these concepts, you can build robust, maintainable, and efficient test automation solutions. Continue exploring the resources provided and apply these strategies to your projects for improved software quality and faster delivery.